Hi and welcome to DCO. My name is David Capetti, and in this video I'm going to be sharing how to take a floor plan like this one and create walls, windows, and doors using Grasshopper. So we'll be programming the script to create the walls, the wall height, the windows, and the doors, and you'll be able to pick the different thickness for the inside walls. We'll be able to pick the height for the door, for the window size, and this will allow us then to, just by using a few base inputs from Rhino, to create a full floor plan, or even just get started with a base floor plan like this. So let's jump right in and let me show you all of the steps involved in getting something like this done. And if you enjoy this content, make sure to like and subscribe. I'll be posting more videos like this. And also consider checking out my website, capettidavid.com, where you'll find more Grasshopper scripts, tutorials, and a few other things related to parametric design. The first thing I'll do is I'll go here to File, New, and I'll have a new Grasshopper document. And I'll go here inside of go here to Google. And I'll try to look for a floor plan. Oh man, here. I'll do a small floor plan, so we'll call this a studio floor plan. And we want something that has basically outside walls and inside walls, but nothing too complicated, in the sense that we can always make it more complicated, but we don't want to, we want to keep it simple for this exercise. So let's go here and look for, let's say even this one. Okay. I'm going to take a screenshot of this. So to take a screenshot on Windows 11, you hold down Shift, then the key for Windows, and then S. Or you could just take a screenshot using the print screen. I'll take this and I'll, now that I have this copied, let's go here to copy, and I'll go here inside of Rhino. Now I'll go ahead and paste it. So I'll go to Control V to paste. It's going to prompt me to paste the picture. Now we can save this picture, and it's going to save it in the default layer. So I'll go ahead and change that to layer 1. So I'll go right click on layer 1, change object to layer, and call this floor plan. Now the thing that we want to be aware of is what units we're using here. So I'll type in units, and it's in feet. So whatever dimension you want to use for the walls, that's what you want to use for the units on the project. So on mine, I would want to use inches because I want my walls to be, let's say, 6 inches or 12 inches. So I'll be using the inches, and it doesn't matter if it's decimal or feet and inches. So we'll hit OK. It's going to try to rescale it. We'll just hit yes. And now we'll take this and scale it using one of these dimensions. So I'll double click here on top view. And now type in scale. Go to the first dimension, and you want to pick the biggest dimension. This way it has better accuracy. Now I kind of covered that with the heart, so it's okay if we go from the center of this line to the center of this line, and we type in 14 feet. Now although my units are in inches, I can type in 14 feet and it will know what I'm talking about in terms of feet and inches. So now that I have this here, let's move that around. And I use the gumball to move things in X or Y, but I also use this little square thing, which allows you to move it on the same plane, but in any direction. Sometimes I use this to kind of move things around, and I'll leave it here within kind of the positive X and Y. And now I can kind of get started with the script, which is going to need 2 inputs. So the first input that I'll use is going to be this layer 1, and I'll type in exterior walls. And for layer 3, I'll double click here and go to interior wall. The reason for this is because we're actually using two different inputs here inside of Grasshopper. And let's actually, real quick, let me move this around. Show you here in this Rhino mode that now we have this. I can lock this layer, floor plan layer. Now we can trace the inside and outside walls, which we'll be using as different inputs inside of Grasshopper. So let's start here by creating the exterior wall. And I'll be going to the outside face. So I'll just click here to the outside, which is going to be different than the inside walls. This last one, I'll hover over this last point, making sure that I have Smart Track on, and I can use that as a reference point and drag this out, and then go here to C, enter to close. Now we need to do the inside walls. For this, it's going to be a little bit different because we know that this wall here is going to be offset one way, and this one is going to be offset off of the middle. So keeping this in mind, we can now go here to interior wall. We'll create a line, and this line will make sure that it goes from all the way this outside face, or actually from here, from the inside, a little bit to the inside. I'll drag this here. And use this with Smart Track to hover, create a reference point, and then bring this all the way back. And this lastly, this one, it's going to be down the center. So I'm actually thinking out loud here, and that since these inside walls are going to be a different thickness than the outside ones, I'm going to delete this and do a line that goes from the center point to the center of each one here. I'm basically creating a polyline that is referencing the center of the wall. So this is all we're going to need to create that parametric floor plan. Let's go here to perspective view. And so now let's go here inside of Grasshopper mode, and let's try to turn this into a floor plan just using these baselines, which means that we could do that to any floor plan as long as we have the outside and inside walls. All right, so now that we have this, let's hide the floor plan. And here's the other thing to keep in mind is when we created these lines, they are polylines, which means that there's more than one line segment within one. And that's just something to keep in mind because we will need to explode those, at least the interior ones, to create that design that we're trying to look for. And so I've also gone over other tutorials on my site or on my YouTube where I share the process for like creating offset lines. And so that's basically what we'll be doing here is let's start by bringing in the outside wall. So we'll go here to a curve component. Now I'll right click here and go to set one curve, and I'll set this outside curve as this line. Now I will group that and then right click on it and call this outside. Outside line or outside wall line. Now that we have this, we'll make a copy of this, right click, set multiple curves, and we'll set these as the next set. So we have this set and this set, and then here we have interior walls, interior wall center, which means that it's going to be a center line. So let's start with our outside line, which we've done before. So we're going to take this and take that curve and first double click and offset. We'll go to offset curve, which will allow us to take this curve and offset it. So we'll plug that into the input. We don't need to change the plane because we are using the same XY plane. But if you were doing this, let's say on an elevation or a different view, you would need to change that. So let's see to which direction it's offsetting it. And it's offsetting it to the outside, which would be fine in different cases. But in this case, we actually want to offset it to the inside. So we'll go here to negative, plug that into the distance. And now into the value, we'll go here to 6.5 for 6.5 inches. Now we see here that approximately 8-inch wall for the interior. Now we'll create a wall in between those two, or a surface in between those two, so I can extrude it as a solid. Double click here. Let's go to boundary surfaces and plug both in, holding down shift to add another input. And then here for edges, we'll right click and flatten the input. Next, we'll take that surface and extrude it out. So we'll go here to extrude. And if we're trying to extrude it up, we will need to go and use the Z vector. So I'll double click, unit Z, and we can plug that into the direction. And now for the factor, that's going to be the wall height. So if you want it to be 10 feet, we can use a mathematical formula that's super simple to do that. So we'll go here to 9.5 for 9.5 feet. And we'll multiply this by 12. So times 12 is going to be 144 inches. So this is going to be outside wall. And this will be wall height. The next step is interior wall center, which are going to be these, right? So now that we have the outside walls, the inside walls are going to be a little bit different. First of all, there are different ways of doing this. So just because I take this direction doesn't mean it's the best way. And if you do have a different way of doing this, then let me know if you found maybe a better way. So we'll take these interior wall center and we'll go to offset. We'll start by doing the same thing. We will offset it. I was thinking we may need to explode it, but we actually may not need to do that because we're offsetting it in two different directions. So let me show you that. We'll go offset, and if we want the wall thickness to be, let's say, 4.5 inches. So this is going to be interior wall, and change this to 4.5. Here's the thing, if you want the wall to be 4.5, then actually you want it to be half one way and half the other. So what we need to do is take interior wall, go here to division by 2, which will give you a division component, which will have A as an empty component and B with 2. So if you go divide by 5, you will get a component with 5 as B. So we can plug this in and just do halfway positive. So we have one value in here, which is 2.25, which is half of 4.5. And then we can offset again, either using the same component. So here's the thing. we can do a negative value and plug this in. So holding down shift, I can add another input, but as you can see, it has to be grafted. So it comes in, it has two different values, right? What we notice now is that it offsets it the way that we're looking for. That's good. Now we need to create the surface in between. I'll double click here and go to loft and plug in here both of these and then flatten the input. Now it's not going to work. And so this is the reason why you do want them to be in two separate inputs or outputs, is you don't want two here. You want this offset, another offset, and instead of grafting it, it will offset it both ways. And this time when we loft it, it won't have issues because of the way that the information is organized. And so here it won't work until we go to graft tree on the top and bottom. What this does is takes the output. So here we have three values, and it lofts them together into one surface. So now let's disable the preview on all of this stuff, including for base curves and this base curve. What I'm doing is I'm selecting these, middle click, disable preview, and I'm only previewing what I'm seeing here at the end. At the edges, you are going to see that to get rid of those creases, we're going to go to merge all coplanar faces and disable the preview here on this loft. Now we can extrude this out the same amount. Now here's the cool thing though, is before we do that, let's disable the preview on the extrusion and see that we can now join these together as one. So where they are separated, we can join them together using region union and then flatten the input. You'll see that now this will be gone. And if I type in boundary surfaces, you'll see that that will be gone. And we can do now the same thing. We can take this and subtract the region of the outside. If we have these, we'll go to region difference. And we'll go curves A, which are these, and curves B, which are surfaces. Here's the thing. The B has to be a curve, and what we do have is a solid, but we don't have it as a curve, but we do have it here. So we'll take this and we'll have to get the edges. We'll go to brep edges, or deconstruct brep, plug in that surface, and then we'll join these edges together using join curve. Now we can use that as the input, and it will now subtract here. If it'll do it too, if I subtract this face, nope. Okay. I need to work on that a little bit, but they're just thinking back, what is the other solution that I can do, right? Thinking out loud is extruding it the same amount. So I'll copy this extrusion using this loft. Basically by extruding it the exact same amount. So whatever those walls are extruded, these are extruded. And now, because we're not doing too many subtractions, we can do a solid difference, which means that we'll take these extrusions in brep A, flattening the input, and plugging in this extrusion as B, which means that it will subtract what is left over and leave us with the interior walls. And if we still have this crease here, we can go to merge all coplanar faces. I'll disable the preview on everything. Now, as you can see, we basically created two sets of walls for a floor plan using one outside wall and one inside. So this region union, what is I extruded that before I joined it together. I'll actually use a Boolean or solid union. Flatten the input, so you'll see here that that kind of fixed that, and then you can use that as the input, and then now we're clean here. The next thing would be to create the doors. And so for doors, there's also two types of doors, right? We have different sizes, we have different shapes, we have different openings, but really what matters the most is the height. So for interior or for entry doors, you're gonna have like 8-foot, 9-foot doors, 10-foot doors. And for interiors, you can go as slow as like 6 foot 8 inches. So that is the next step, is seeing how to create those doors using a script. All right, so let's take a look at the floor plan without any of the Grasshopper stuff. So we'll go here to disable preview, and now we're going to go to layer 4 and change this to doors. And layer 5, we'll call this windows. So we'll start here, doors, and now we're going to create the base geometry for the doors. And now the reason why we create the doors separate is because the doors are going to go from the ground all the way up, and the windows are going to be a little bit different where the height can change. So we'll start here with doors, go to perspective view, or double click on perspective, and let's go to top view. And let's basically create a line segment or a polyline segment from the beginning of the door opening to the end of the door opening. And it doesn't have to be exactly in the center, it could be anywhere in between. So I'm being careful to pick the outside to outside, and also making sure that I kind of got everything here. Now I do know that some, let's say some doors may be smaller than others, but for now we'll just kind of keep it all the same size. And we can have a different size, let's say for the front door, but those details we can kind of do a little bit later. For now, we'll just focus on the overall design. And in general, this is one of the things that I tell people is I like to work general to specific. So this is going to be basically getting the general forms down. Now we'll change now from windows or from doors to windows and change the color here to, let's say, purple. And now let's pick the location for the windows, which will be somewhere around the same. The outside to outside, we can use that reference center line for our window. Now inside of Grasshopper, let's bring in both sets of lines. We'll do the same thing. We'll double click here, go to curve, set multiple curves, right click on top of doors, select objects, and then hit enter. You'll be able to tell that it's working when you select it here and you have this enabled. See it show up here. And now I'll go here to group. I'll select this, Control G to group, and right click on that. Let's change this to door location. Now we know that it's a line or a curve. So what we have to do is the same thing that we did here, which is take that curve, offset it in both ways, and then extrude it up. Now when we extrude it both ways, it has to be more than 8. So we make sure that we do 8, and we can do a little bit more, right? So 8 plus, or 8 times 2 or something like that. This way, let's say if the door, maybe that might not be the best idea. Maybe just a bit more than 8, and we can have a tolerance for that. And the reason for that is because you're not going to be able to pick the exact center location. So if we offset by 8, so 4 and 4, I'm pretty sure this is not going to land exactly in the center. But if we have a little bit more, then we know that as long as we're within the range of that wall thickness, then we should be fine. So these are some of the things that kind of cross my mind when I'm trying to create a script. So with these, I'll basically copy all of this script down here, except for I will reroute these. Because if you think about it, these two inputs are coming out of the same one. So if I were to go like this, we're simplifying it. And then if I go like this, then we are able to do that, right? To basically reroute it using these curves. And we can see that because we have this lock down here, which is 4.5, but we want it to be at least 8.5. But like I said, we need it to be a little bit more. So the tolerance is going to be, if the outside wall is 8, and this has to be by 8, plus and then you can even do 8 divided by 3. So 8 divided by 3 will give us the value of 2, and then that's how much we add to extrude by that much on both sides. And it does it to all of them. This way we make sure that we at least intersect it by that much. Now we can do it by 3, we can do it by 2. That will just give us a different tolerance, but this will make sure, like I said, to just know that it's going to cover and intersect it perfectly. We'll take these, scoot them over. So basically for this, we don't have to pick any we don't have to use a slider because we're using the wall. So if this wall becomes really thick, that also becomes thick. So I think this will go something like that. It's added after the fact. So that's the issue sometimes with doing it to the outside, is that let's say if the outside wall was going to be 3.5, then we have to change this number of the division. So it does work. Here's the thing. When that happens, then even this starts happening. So that is something also to keep in mind, is that if something like this starts happening, then we have to turn on these, go to F10, and then start editing these so they do match. You can select that curve. We'll go to the point, move it into place. Here's the thing. Line. The thing is, even if I do this and now we thicken it out, it will still subtract it because we did the Boolean difference thing. And now we would need to do something like this. So this is going to be the factor for, so. Now let's take this and extrude them to create the door height. We'll go here to extrude curve. So double click, extrude, direction, unit Z, and factor is I'll copy. I can't copy that one because it's divided by 2. So I'll just go here to 8-foot doors and then do times 12. This will give me 8-foot doors in inches, 96. And now we can subtract the doors from the outside walls. So let's go to our walls, inside walls, for the most part, and one outside wall. So we need to do 2 solid difference. One for the outside, one for the inside. Let's plug the outside into A and this outside into A, and then plug this one, both of them into B. And when you have those dashed lines, which means that they're all coming in as different groups, not as one list, this is where we'll actually flatten the output of this. Now let's disable the preview on everything else and see that now we have created those parametric doors. We also have the ability to scale them down and make them smaller, but the point is that we can do that by hand, right? We can come in here, and if I want that door to be bigger, then I can switch that out, move that around. And here we're having an issue, and that is the same issue that we talked about, where if we have this factor, preview the door. Now this one is the one giving us an issue here. Basically, if I just move it over this way, it will work. But you'll be able to see that now that we have that fixed, it should be good. In the sense that now we can disable the preview on this and we should be good to go. The cool thing is that we also have, if we were able to do a Boolean difference, we can also do the intersection. So we'll go here to Boolean intersection or solid intersection, and we can bring in this intersecting with this. Will give me the doors. Here to flatten the input. It's gonna have to be graphed on this one. Because graphed, that means that it'll do it to all of them in a separate list and only do one of these. If I disable the preview here, pretty sure that if I do graphed here, it's not gonna work. This will work, but just make sure we don't do anything. And now disable the preview on this, and you'll see we have a door location. So that's the other cool thing, is that with Boolean difference, we were able to get the subtraction of it. Now let's see why. Oh, the reason why I couldn't do this one is because we did not plug that in. This is the outside wall. Now, it was missing one wall that it could plug in. So when we do all of this extrusion, do it at once, and then we can also I'm basically changing the wall height a little bit so we can looks a little bit more proportional with the door location. Now, next thing, let's go to the windows. So let's hide everything else. I'll select those lines, double click here and go to curve. And I'll go here to set one curve, or it's going to be wrong, set multiple curves. Then I'll take this, Control H to hide, and we'll bring back our preview here. Here's the thing, with Windows, it's a little bit different. You don't want to extrude up, you want to move up to the head height. So when you look at the windows in a house or in a typical house nowadays, you're going to find something called the head height, which means the location of the highest place where your windows are located, and they're all located generally in that location. The only things that change will be, let's say, in a bathroom where they could be higher. So that is kind of the standard. So we'll take this and we'll go to move, and we'll take this line and we'll go here into geometry, motion. We need to move it up, so we'll go to unit Z, and we want to move it up to the same location as the door height, door head. So we'll move this, and I'll change also slider name here. This is going to be door height. Instead of creating a new slider, I'll copy this down. So I'll slide this down here, tap Alt. Now plug that in. Here's the thing. If it's the same location, we can save some time and plug that right into this one. And now when we offset to create the surface that we're going to extrude down, we're going to be doing it from up here because that's the location of the window. Here's the thing. Some of the steps we've already created, so we can save some time and copy them. And that's the cool thing about parametric design, is that if you've already done steps, you can we can copy them again. And you can't really do that in 3D, just regular 3D modeling, where you can't borrow steps that you've done before unless you're just going to copy and paste, but not like an entire set of steps. So here with this one, we can take this, which allows us to offset it using positive and negative. So we'll copy this down and plug this as an offset line, and we'll enable the preview here. So I basically copied those steps here and move this around. Now we're going to take this surface and extrude it down. So the opposite of what we've done with the other ones is extrude them up. We're going to extrude them down. So we'll go here to extrude, then negative, then Z, because we want to extrude down. So up and down is Z, negative is down, and factor is going to be the height of the window. So 4 feet. So we can copy the door height times 12, and then basically just copying the unit conversion into inches. And it creates basically a door size because it's the same size. So now it's window height, because the length is picked when we did the line. And we'll change this down to, here's the thing, if you're at the same size, you need tempered glass. If you have 2 feet less, you still need tempered glass. But to not have tempered glass, which sometimes it doesn't matter if you want to have a tempered glass, it's just sometimes the code stuff kind of comes into mind. But with this, now we can take the same approach, right? Since we have the solids that we want to extrude, or that we have extruded, we know we need to intersect it with the inside and outside walls. So we'll do the same thing. We'll take these and let's input these as additional inputs for the B rep B. So let's see if that works. Otherwise, we can do that as a separate step after. So we get to pick which way or which direction we want to take the script, depending on whether you do things before or after. So this is something else that I want to share a little bit more coming down here on this channel. Let's see if we add an additional B input, flattened, and then additional B input here. Which didn't really need it, but it's there just in case we do happen to add a window or something there. Now we can take all of this, disable the preview. Now do the intersection game with this one. Here's the thing. Doors and windows are going to want to be separate, but that in general, that kind of creates the overall form of a floor plan. Now, what I would suggest is rather than having to develop this completely here in Grasshopper, this gets you a long way into creating a floor plan when all you need are these basic lines. I'll type in show all of these lines, and then disable preview on here, and just show how simple the lines you need to create a floor plan. These will be the outside, inside, doors, and windows. So let's finish it out, and let me show you some last things that kind of come into mind. Right, so now that we have that kind of complete there, let's bring back everything. Let's hide all of this. So middle click, disable preview, and then we'll preview this one. Now to organize these, I select them, click on this one to evenly space them, and then use this one to align it to the right. And so now we can have these as separate outputs. And lastly, we can take the outside wall line bring in a boundary surface, and we'll use this surface. I'll actually slide it all the way down here because this will be the ground slab. So we'll use an extrusion. We'll go here to extrude. I was going to say I might copy that extrude, but now I'll just use this, plug that into the base in the direction we know we want to go down. So we'll go negative and then Z, and we'll use a 8.00, so it'll be a ground slab of 8 inches. And it will go, I think, down. Yep. Let's disable preview and call this floor slab. Now I do have other tutorials where I've gone over how to do something like this before. I've also shown how to create a foundation for it. And so from here, there's a lot of things that we can do just using that baseline, and we can kind of program those steps further. Like we can also create a roof for this. So I am now just going to create a new layer, call this 3D model, and create a layer below that. So a sub layer, call this wall 1, hit tab, wall 2, and then window / door. And also floor plane or floor slab. All right, so now let's go here to wall 1, and we'll use the outside wall, middle click, then bake. Wall 2, we'll do the interior wall, middle click and bake. We'll go to window and door, select this, middle click, bake, and lastly, floor slab. Make that my current layer and do the same thing. I'll go here, let's go back into Rhino mode, and let's bring back the floor plan. Now all of these are going to be the base geometry, so we can, I would like to go to this default layer, change the name, and call this base geo for base geometry, and we can take all of these and drag them right under the base geometry. Hide that also. And actually, I do want to bring I want to have this as my current layer and be able to hide these. Oh, where's the floor plan? Okay. I want to take the floor plan out of there, hide base geometry, and let's go here into shaded mode. What's getting in the way is floor slab, so I'll hide that. And so with this, we can now actually create a floor plan fairly quickly. Let me show you actually some steps here that I like to use. I'll hide the floor plan, type in shell, and pick the thickness. So the thickness is going to be 1 inch for the frame. I'll hit enter. Now I'll pick this face, and this face, which will create a door frame. So one quick way of doing that is hitting enter and selecting these. To create the frames for the window, I'll do the same thing. Just pick both sides there. So when you pick shell, it creates, it gives it something a thickness, and when you pick both sides, it basically creates some outer wall like this. So this would create that base geometry. Let's go here to presentation 1. And what I've done here in this mode is have it using Arctic, but also enabling curves. This way you can kind of see the outline and it looks a lot cleaner.